something is pushing up from below. Deep under the ice on the remote Alaska Peninsula, the ground is swelling. It's a slow, silent, almost imperceptible change, but satellites passing hundreds of miles overhead see it clearly. Their radar pulses paint a picture of a planet taking a deep breath. The ground is literally bulging upwards. This is happening at a place called Mount Kupreanof, a heavily glaciated stratovolcano that until recently was just another anonymous peak in a land of giants. But in February 2026, it started to tremble. It has no known history of eruption. None, for as long as people have been watching. For all of recorded history in this part of the world, Kupreanof has been dormant. A virgin volcano. And that is exactly what makes the current situation so unsettling. Because when an ancient system stirs for the first time in memory, no one knows the rules. No one knows what it's capable of. The models, the predictions, they're all based on history. But Kupreanof has no history. Only a future that is being written right now by a new batch of magma intruding into the shallow crust. The scientists at the Alaska Volcano Observatory can see it. They can measure the sulfur dioxide gas seeping from the ground, sometimes over 1,000 tons per day. For a volcano that's supposed to be sleeping, that is a terrifyingly large number. They can see the swarms of low-level earthquakes. What they can't see is what happens next. This isn't some abstract geological event. This is the prelude. And it begs the question that hangs over this entire region. Which biggest volcano are we even talking about? The title of biggest volcano in Alaska is a contested one, a crown with a few different claimants, and the answer depends entirely on how you choose to measure a monster. If you measure by sheer mass, by the total cubic volume of rock and ice piled into a single geological feature, the undisputed king is Mount Wrangell. Located in the magnificent isolation of the Wrangell-St. Elias National Park, it is a behemoth, a true giant. It's one of the largest continental margin volcanoes in the entire world. At 900 cubic kilometers in volume, it's a staggering pile of earth. To put that into perspective, it's more than twice the mass of California's famous Mount Shasta. But Wrangell is a shield volcano. Its eruptions, historically, have been effusive, with flowing lava. Dangerous? Yes, but not the type of danger that threatens the entire globe. If you measure biggest by footprint, by the sheer amount of land it covers at its base. Then the title belongs to Mount Kupreanof. This absolute unit is nearly 20 miles across. It's so wide, it contains a massive caldera, a collapsed summit from a prehistoric eruption that is itself filled with a sprawling glacier. Kupreanof is active. It puffs, it steams, it occasionally has minor eruptions. It's a constant, simmering presence. But the most terrifying metric isn't size. It's lethality. It's the potential for a single explosive event to reach out and touch civilization hundreds or even thousands of miles away. And by that measure, Alaska's biggest threats are often its most volatile, not its most massive. And one of them sits just 75 miles west of the state's largest city. They call it the monster volcano. Mount Spurr. It's an 11,000-foot stratovolcano in the Tordrillo Mountains, and its proximity to Anchorage makes it a permanent lurking menace. In early 2024, that menace became very real. The ground began to shake. Seismometers detected a deep, persistent tremor. Satellites observed the ground surface deforming. Matt Haney, the scientist in charge at the Alaska Volcano Observatory, or AVO, watched the data with growing concern. In an official statement, the AVO was blunt. The current unrest at Mount Spurr indicates that new magma has intruded into the Earth's crust beneath the volcano and that the probability of an eruption has increased. The media seized on it, with headlines blaring about a 50-50 chance of an impending eruption. For the residents of Anchorage, this wasn't just news, it was a memory. Spur had erupted violently 3 times in 1992, burying the city in a blanket of gritty, gray ash. It shut down the airport, paralyzed the economy, and served as a stark reminder that they live in the shadow of an active volcano. While the unrest at Spur eventually subsided by mid-2025 and the alert level was downgraded, the event was a dress rehearsal. It proved how quickly a seemingly quiet mountain could wake up and threaten a major population center. But the real globe-spanning danger isn't necessarily the lava or the blast. It's the ash. A fine, insidious powder that can travel farther and cause more widespread chaos than anyone imagines. To understand that, you have to go back to a cold December night in 1989. You have to climb into the cockpit of a Boeing 747. On December 15th, 1989, KLM Royal Dutch Airlines Flight 867 was cruising at 27,900 feet en route from Amsterdam to Tokyo with a stopover in Anchorage. It was a routine flight. The 231 passengers were settling in. The 14 crew members were running through their checklists. The jet, a brand new 747-400, was one of the most advanced airliners in the world. As they began their descent toward Anchorage, the pilots noticed a strange brownish haze ahead. Air traffic control reported nothing unusual. Another volcano, Mount Redoubt, had erupted the day before, but the ash was believed to be far away. They flew into the cloud. The cockpit suddenly filled with a thick, acrid, sulfuric smell. A bizarre, dancing electrical phenomenon, like St. Elmo's fire, began to crackle across the windshield. On the engine instruments, the dials went haywire. Then, one by one, the engines began to fail. First number 1, then number 2, then, in terrifyingly quick succession, 3 and 4. Silence at nearly 28,000 feet. A 400-ton jumbo jet with 245 people on board had just become a glider. All 4 engines were dead. The captain, in a voice strained but steady, came over the intercom, "Ladies and gentlemen, we have a flameout of all 4 engines. We are making an emergency descent." The plane was falling. It plummeted out of the sky, dropping at an alarming rate. 14,000 feet in just a few minutes. Over the jagged, snow-covered peaks of the Talkeetna Mountains. The cabin was dark. The only sound was the rush of the wind and the frantic work of the pilots in the cockpit. They were running through a checklist that was never meant to be used. The all-engine flameout procedure. Over and over, they tried to restart the engines. Nothing. The plane dropped through 20,000 feet. Then 15,000. They were getting dangerously close to the mountains below. They tried again and again. Finally, as the jet fell through 13,300 feet, engine number 1 sputtered back to life. Then number 2. They managed to coax life back into all 4 engines just in time, leveling off and limping toward Anchorage. They landed safely, but the ordeal wasn't over. The plane was, for all intents and purposes, destroyed. What the investigators found was shocking. The abrasive cloud they flew through wasn't smoke. It was volcanic ash, microscopic shards of jagged glass and rock. It had sandblasted the cockpit windows, making them opaque. It had contaminated the fuel systems, and inside the engines, it had melted from the intense heat, then resolidified into a glassy, cement-like glaze, choking the turbines and starving them of air. The cost of the damages was a staggering $80 million. The National Transportation Safety Board's final report identified a critical failure: the lack of available information about the ash cloud to all personnel involved. This is the hidden threat of Alaska. It sits directly on the Ring of Fire, a chain of seismic fury. The Aleutian Arc alone, that long chain of islands stretching out into the Pacific, contains over 50 historically active volcanoes. And directly above this arc are some of the busiest international flight paths on Earth. These are the Great Circle routes connecting North America to Asia and Europe. Every day, hundreds of flights carrying tens of thousands of passengers and billions of dollars in cargo fly directly over this volcanic minefield. The work of volcanologists like the late Jürgen Kienle of the University of Alaska Fairbanks was instrumental in first documenting this specific, dire threat to aviation. He understood that volcanic ash wasn't like regular smoke or dust. He knew it was a machine killer. This isn't the soft, fluffy stuff from a campfire. This is rock, pulverized into a fine powder by the sheer explosive force of an eruption. Under a microscope, each particle is a razor-sharp fragment of volcanic glass. When a jet engine, which operates at temperatures hot enough to melt rock, ingests this powder, The particles flash melt into a molten silicate liquid. This liquid then coats the air cooling passages and turbine blades in the hottest part of the engine. As it cools slightly in the downstream sections, it solidifies into a hard, glassy crust. It's like pouring cement into the delicate, high-speed machinery of a jet turbine. The airflow is blocked. The engine suffocates. It flames out. That's what happened to KLM 867. And what happened to that flight was the result of a relatively small eruption from Mount Wrangell. What happens when a truly massive Alaskan volcano lets go? To answer that, we have to look back more than a century to the single largest volcanic eruption of the entire 20th century. An event so powerful, it literally blew a new hole in the planet. On June 6, 1912, the world's attention was elsewhere. The Titanic had sunk less than 2 months prior, but on the remote Alaska Peninsula, something far more powerful was stirring. For days, the ground had been shaking violently. Then, the earth ripped open. But the eruption didn't come from where everyone expected. Mount Katmai was a known volcano in the region. But the blast, when it came, erupted from a previously unknown vent about 10 kilometers away. A fissure that would come to be known as Novarupta, or New Eruption. For 60 straight hours, Novarupta disgorged a cataclysmic volume of incandescent ash and magma. It was an eruption on a scale that is difficult to comprehend. It ejected somewhere between 13 and 14 cubic kilometers of magma. That's 30 times more than the 1980 eruption of Mount St. Helens. The ash column rocketed into the sky, reaching an altitude of 100,000 feet, punching through the troposphere and deep into the stratosphere. For the people in the nearby town of Kodiak, about 100 miles away, the world ended. A massive, dark cloud blotted out the sun. For 3 days, the town was plunged into total, suffocating darkness. You couldn't see a lantern held at arm's length. The air was thick with ash and the smell of sulfur. It rained ash, a gritty, heavy blanket that collapsed buildings under its weight. People huddled in their homes, terrified, listening to the constant rumble and the sound of ash piling up outside. When the sky finally cleared, the landscape was alien. Everything was buried under more than a foot of gray powder. Rivers were choked, fish died, and the entire ecosystem was devastated. But the impact wasn't just local. The Novarupta ash cloud was so massive it was carried by the jet stream across the globe. Ash fell on Seattle. It fell on Vancouver. The cloud was tracked across the United States. And it didn't stop there. The finest particles, the sulfurous aerosols, stayed suspended in the high atmosphere for months, circling the globe. They caused a measurable drop in global temperatures, and, almost 2 weeks after the initial blast, reports came from halfway around the world. From North Africa, a strange sulfurous haze was observed, and a fine, acidic dust fell from the sky over Algeria. It was ash from Alaska. This is the precedent. This is the benchmark for what an Alaskan super eruption can do. It can reach out and touch continents. It can alter the climate. And it created the landscape we now call the Valley of 10,000 Smokes, a barren, alien terrain still steaming from the heat of that cataclysm over a century later. It's often mistakenly attributed to Mount Katmai, because Katmai's summit collapsed to form a caldera as the magma chamber beneath it emptied out through the Novarupta vent. It was a geological bait and switch. The smoking gun was 10 kilometers away from the body. This history hangs over every new tremor, every puff of steam, every new report from the Alaska Volcano Observatory. The scientists at the AVO, a joint program run by the USGS, the University of Alaska Fairbanks, and the state's Geological Survey Division, are the frontline sentinels. They use a network of seismometers, GPS stations, satellite data, and gas-sniffing aircraft to keep an eye on these dozens of sleeping giants. They run computer models, like the PUF model developed at the UAF Geophysical Institute, to project where an ash cloud might travel, giving airlines precious hours of warning. But their job is getting harder, and the stakes are getting higher. Which brings us back to today. Back to 2026. Back to that silent swelling on the Alaska Peninsula. The unrest that began beneath Mount Kupreanof in February 2026 wasn't a sudden bang. It was a slow, creeping realization. First, the sustained swarm of earthquakes. Then, on May 12, 2026, the AVO made a critical decision. They officially raised Kupreanof's alert level from unassigned to advisory, and the aviation color code to yellow. This wasn't a guess. This was based on hard data. Satellite instruments detected highly elevated emissions of sulfur dioxide gas between 100 and 1,000 tons per day, far above the background level of less than 100 tons. Sulfur dioxide is the telltale breath of fresh magma rising from the mantle. Then, in mid-June, came the smoking gun. Using a technique called interferometric synthetic aperture radar, or INSAR, scientists got their first clear picture of the ground deformation. By comparing satellite radar images taken at different times, they can detect millimeter-scale changes in the ground surface. The data confirmed it. A patch of ground around Mount Kupreanof was actively bulging upward. This wasn't a landslide. It wasn't a seasonal shift. This was the physical manifestation of a new batch of magma pushing its way into the mountain's plumbing system just a few miles below the surface. This is when a volcano is at its most unpredictable. It is waking up. And Kupreanof has a terrifying vulnerability for the scientists trying to monitor it. There are no local seismometers on the mountain itself. The closest one is 17 miles away, perched on the flank of its larger neighbor, Mount Kupreanof. This means the AVO has a significant blind spot. They can detect the larger earthquakes, but any tremor below a magnitude 2.0 is likely completely missed. They can't pinpoint the exact depth or movement of the magma with the precision they would want. They are watching a dangerous animal, but they're doing it from a distance, with one eye closed. And as if to underscore just how unpredictable this region can be, on July 16, 2026, something happened 150 miles to the southwest at the Alaska Volcanic Complex. At 3:55 am local time, Corvin Volcano, another peak in the chain, exploded. It was a small phreatic, or steam-driven explosion at its crater lake. What was so alarming about it was that it happened with virtually no precursory warning. There was no sustained earthquake swarm, no significant ground deformation. It just blew. The AVO scrambled, immediately raising the alert level to yellow. It was a violent geological jump scare, a stark reminder that, even with all the modern technology, these mountains can still blindside you. So now you have two situations running in parallel. At Kupreanof, a slow, well-documented, and deeply ominous awakening of a volcano that has never erupted in human history. A mountain that is physically swelling with magma. And at Alaska, a sudden, shocking blast from a known actor, proving that even the ones you think you know can lash out without warning. Every piece of information, every data point, is filtered through the lens of history. The 1912 Novarupta eruption showed the scale of the potential devastation. The 1989 near disaster of KLM Flight 867 showed the specific lethal danger of ash to our modern technological world. The 2024 unrest at Mount Spurr showed how close that danger is to major population centers. The world economy runs on air travel and just-in-time global shipping. An eruption like Novarupta today wouldn't just be an Alaskan problem. It would be a global crisis. It would ground tens of thousands of flights. It would sever supply chains. The economic damage would be measured in the tens, if not hundreds, of billions of dollars. And it would all be caused by a cloud of pulverized rock launched into the highway of the sky by a geological engine that has been running for millennia. The question isn't whether another major Alaskan volcano will erupt. That is a certainty. There have been dozens of eruptions in the last century alone. The Aleutian Arc is one of the most volcanically active places on the planet. The real questions are, which one will it be? And will we be ready? Will the warnings be clear enough? Will pilots and air traffic controllers have the information they need to avoid a repeat, or worse, of what happened to KLM 867? As of right now, in the summer of 2026, the seismic unrest at Mount Kupreanof continues. Low-level earthquakes persist. The ground continues to hold its breath. And the scientists at the Alaska Volcano Observatory continue their vigil, staring at their screens, watching the data streams, trying to interpret the whispers of a giant that is slowly, inexorably beginning to stir from a very long sleep. They are listening for the first signs of the roar, hoping to give the world a warning before the sky turns dark. Because under all that ice, deep in the crust, something is moving, and it wants out.